Hey guys, this is Mrs. Raro and I'm going to teach you how to operate with functions. Okay, so let's begin. Combining functions, so operations with functions, uses arithmetic operators. So arithmetic operators are sum, difference, and product, or adding, subtracting, and multiplying. So let's pretend there are two functions here, identified as one is x squared, named f, and then one is absolute value of x, named g. Okay, so we're going to add them, subtract them, and multiply them. So in the first example here, you can see that I'm adding these to f and g, right? So this has nothing to do with multiplying by x. So we simply just add f of x, which is represented by x squared, and then g of x, which is represented by absolute value of x. Now these two can't be combined anymore because they're not like terms. Okay, if there was another x squared, then you can combine it with this x squared. If there was another absolute value of x, then you can combine those two together. But right now, this is your final answer because they are not like terms. All right, now the difference. All right, difference means to subtract. So same idea, x squared is f, and then absolute value of x is g. So you just subtract them. Product means to multiply. So when you multiply, there are two notations to multiplication. So either it has this circle, dark circle filled in, or it just says fg. Okay, so fg of x is also multiplication. All right, so same idea. We have x squared times absolute value of x, or it could be read as x squared absolute value of x, okay, without the dot. So with or without the dot, that represents multiplication. All right, so as far as quotient is concerned, I'm going to skip that one out. You'll know for the purposes of later in polynomial functions, chapter 3. All right, so let's look at other examples. Okay, so for example, here we have two functions, f of x equals 3x squared plus 2x, and g of x is equal to 1 minus 2x. Okay, so this is f and this is g. If h of x, so as you notice, h of x is a new letter, meaning a new function, and what they want you to do with that function is they want you to add these two previous functions that were mentioned, f and g, all right, to determine a new rule for h of x. So let's begin. H of x is identified as f of x plus g of x. So I'm going to use red for f, and I'm going to use blue for g. Same idea, I'm just going to bring down my f of x, 3x squared plus 2x, and I'm going to bring down my g, which is positive 1 minus 2x. Okay. All right, now from here, all I'm going to do is combine like terms. So my like terms here are, I'm going to start with the highest exponent first, so 3x squared goes first. And there's not another x squared, so I will just bring that down. Okay. And then the next thing is my 2x and my negative 2x. So since they cancel out, I don't need to write 0x in the middle. And my final term there that's left is this plus 1. All right, so that's your final answer, 3x squared plus 1. Let's just double check to see if we're correct. That is right, so letter A, okay? All right, now the next one, I would like for you to do it again, except I want you to explore how to subtract. All right, so based on what you know about subtraction, here we have h of x is now identified as f of x minus g of x. And you want to be careful with subtraction, okay? So here's the reason for that. So I'm going to bring down my f of x, 3x squared plus 2x. All right. Normally, you bring down your subtraction sign and then you bring down your g of x, right? So this is actually incorrect. The reason why is because you're subtracting g of x, which has multiple terms. All right. So when you have multiple terms, you want to use parentheses, okay? Right, that's going to make a big difference because you're not only subtracting a 1. So without the parentheses, let me undo my parentheses. So without the parentheses, this means that you're just subtracting a 1. That's all that means, right? You're not subtracting just a 1, you're subtracting a 1 minus 2x. So you're subtracting a 1 and you're subtracting a 2x. So what that does is that it distributes this negative twice, once to the 1 and then another time to the negative 2x, making this one a positive 2x. Okay, that's the difference. And you'll see later on that that makes a world of a difference when you combine like terms. So now our final answer is going to be 3x squared. Now it's going to be plus 4x, right? and then minus 1. Okay, so our final answer there is D. Okay, let's check to see if we're correct. And we are. All right, let's take a look at another example, this time multiplication. Okay, so again, same idea. We're identified as two of the same f of x and g of x, but this time I want to multiply. So same thing goes, h of x is f times g, f of x, and then times g of x. All right, that's a dot. All right, so I'm going to have my 3x squared and my 2x, and I'm going to put that in parentheses, and you'll see why in a bit. And then g of x is 1 minus 2x, okay? And if you remember from Algebra 1, we had this method called FOIL, all right? And FOIL stands for first, outer, inner, last. And it's a mnemonic for you to help you with the distributive property. So technically, this is the distributive property. You want to multiply these two terms by these two terms in this order. So F stands for first. So this is your first term and this is your first term. So we multiply these two together. So 3x squared times 1 is 3x squared. Okay. O stands for outer, and these are your outer terms right over here. Okay. So these two terms, 3x squared and negative 2x, is negative 6x cubed. All right, the reason why it's cubed is because you're multiplying an x squared here and x to the first here. When you multiply, you add the exponents. Okay. Now I stands for inner, so these are your inners, right? They're like inside the parentheses. Oh, guess next to each other, right? So 2x and 1 makes times 1 makes positive 2x. And then L stands for last. So these are your last terms, okay? So 2x times negative 2x is negative 4x squared. Okay, again, same idea. Why you add the exponents here. So x to the first times x to the first is x to the second power. Okay, so now we're going to rewrite this all in standard form. So standard form means it's going for the highest exponent all the way down to the lowest, okay? All right, so negative 6x cubed goes first because there is no other x cubed that we can combine it with. 3x squared and negative 4x squared becomes negative x squared. And then I am done. I just have to bring down my positive 2x. All right, so that is letter D, okay? And that's how you multiply, subtract, and add. In this slide, I'm going to show you how to evaluate after we have added, subtracted, or multiplied. So this is fairly possibly like the next step to it. So if they ask you to evaluate such expressions, what they're asking you to do is they're asking you to add functions f and g and then put in 9, for the x. Okay, so evaluate it with x being 9. That's what that means. All right, so I'm going to do the same thing. I'm going to add first. So the square root of x is f, and then plus 2x plus 1, which is g. All right, there's nothing I can combine here. So from here, I'm just going to do straightforward. Plug in a 9 for every x that I see. So this is the square root of 9. All right, and then plus 2 times 9. All right, and then plus 1. And I'm going to evaluate that. So that is going to be the square root of 9 is 3. 2 times 9 is 18. And then 18 plus 1. All right, so 3 plus 18 is 21. 21 plus 1 is 22. That would be your final answer. Okay. All right, next. They want you to subtract f minus g, and then they want you to plug in a 4 for x. All right, so same idea. So I'm going to write the square root of x as f. And then minus, and again, be careful. You want to use parentheses for subtraction. Okay, so this is 2x plus 1. But like I said, if there are multiple terms, if you're subtracting things that are multiple terms, then you need your parentheses. But if it's only like one term, then you don't. Okay, so let's begin this process here. So I'm going to take the square root of 4 and then minus, and you can distribute the negative or not if you're evaluating. So this is 2 times 4 and then plus 1. Okay, so all I did there is substitute. All right, now I'm going to evaluate. So the square root of 4 is 2, right? Minus, and then again that parentheses. 2 times 4 is 8, and then 8 plus 1 is 9. Okay, so 2 minus 9 is negative 7. All right, cool. All right, last one. F times g of 16. So I hope this goes the square root of x, and then parentheses 2x plus 1. All right, so that means multiplication. If you want to put the dot there, you can. Excuse me. Okay, so now I'm going to evaluate. All right, so the square root of 16, and then multiplied by 2 times 16, and then plus 1. All right, and now I'm going to evaluate that. So the square root of 16 is 4, okay? And then times, 2 times 16 is 32. 32 plus 1 is 33. Okay, so 4 times 33 is 120 plus 12 becomes 132. All right, and that is it. Thank you for watching.